Assalamualaikum and greetings everyone. Welcome to my final year project presentation. Before we start, let me first introduce myself. My name is Muhammad Faris bin Haris Padzilah, an undergraduate student under supervisor Dr. Sheikh Ahmad Zaki bin Sheikh Salim, Faculty of MJIT in the Department of Mechanical Precision Engineering. My FYP title is about airflow and thermal comfort in a cooling vest using computational fluid dynamics CFD. To start off, did you know that during performing activities in hot environments, the human body has its own mechanisms to thermoregulate its temperature, or in other words, maintaining a normal body temperature range, and that is by sweating and vasodilation. Cooling is achieved through this mechanism to keep the core body temperature within a narrow and acceptable range to, to allow normal functioning of the internal organs. However, in hot and humid environments, it is difficult for the body to maintain a stable core temperature without the aid of external cooling. In such environments, workers may be at risk of heat stress, which could lead to severe problems such as fatigue, heavy sweating, dizziness, and many other else. Moreover, hot conditions have been shown to increase the workers' fatigue level, therefore forcing them to increase their rest time and to decrease their working time, subsequently resulting in a significant decrease in their output. To reduce the heat stress of the workers, one of the proposed cooling techniques is by using cooling vests. Cooling vests are designed to help keep the core body temperature lower, preventing heat exhaustion and other negative effects of overheating. There are many types of cooling vests, and the most common type of cooling vests are evaporative cooling vests, fan-powered cooling vests, phase change cooling vests, and circulatory powered cooling vests. As my FYP is about airflow, I will be focused on the fan-powered cooling vest. First, the model of the cooling vest is generated using SolidWorks. This is the preview of the cooling vest model. It has zip in the middle, two pockets on the front. For my research, I will run the simulation analysis using Computational Fluid Dynamics (CFD) on the cooling vest equipped with two fans, and also on the cooling vest equipped with four fans to observe the difference. During the simulation, variables such as value of mass flow rate, pressure, percentage of humidity, speed of fan, and material used for the cooling vest were made constant throughout all the simulation. This is the constant variable value. Mass flow rate is 0.0001 kg per s. Pressure is about 101,325 Pascal. Humidity 75%. Speed of fan is about 1432 RPM or 150 rad per second, and material used for the cooling vest is nylon. I will run the simulation in three different temperature, which is 28 degrees Celsius, 35 degrees Celsius, and lastly 40 degrees Celsius. Now, let's see the simulation analysis on the cooling vest equipped with two fans on the three stated temperatures. First is the 28 degrees Celsius. This is the preview of the airflow of the cooling vest, and to see the temperature gradient more clearly, there is also the cut plot of the cooling vest. From the result I got, the cooling vests were able to cool down to 294.62 Kelvin or 21.47 degrees Celsius. The max predicted mean vote PMV value of the cooling vest is about 1.32, and here is also the value of the predicted percentage dissatisfied PPD. PMV is an index that indicates whether it is too hot or too cold on a 7-point thermal sensation scale, and PPD is an index that indicates the percentage of thermally dissatisfied occupants. Now, on to the 35 degrees Celsius. This is the preview of the airflow and the cut plots. From the result I got, the cooling vests were able to cool down to 295.87 Kelvin or 22.72 degrees Celsius. This is the PMV and ppd value. Now, on to the 40 degrees Celsius. This is the preview of the airflow and the cut plots. From the result I got, the cooling vests were able to cool down to 296.30 Kelvin or 23.15 degrees Celsius. This is the PMV and PPD value. Now, let's see the simulation analysis on the cooling vest equipped with 4 fans on the 3 stated temperatures. First is the 28 degrees Celsius. This is the preview of the airflow of the cooling vest and the cut plot of the cooling vest. It were able to cool down to 294.01 Kelvin or 20.86 degrees Celsius. This is the PMV and PPD value. Now, on to the 35 degrees Celsius. This is the preview of the airflow and the cut plot. It was able to cool down to 293.47 Kelvin or 20.32 degrees Celsius. This is the PMV and PPD value. Lastly, the 40 degrees Celsius. This is the preview of the airflow and the cut plot. It was able to cool down to 293.79 Kelvin or 20.64 degrees Celsius. This is the PMV and PPD value. In conclusion, the cooling vest equipped with 4 fans shows a better result in reducing the surrounding temperature compared to the cooling vest equipped with only 2 fans. However, the thermal comfort parameters PMV and PPD value of the cooling vest equipped with 4 fans is much higher than the cooling vest equipped with only 2 fans, thus indicates that in terms of thermal comfort, cooling vest equipped with 2 fans is the better choice compared to the cooling vest equipped with 4 fans. In this era of global warming, hot environment is one of the main causes of heat stress that is affecting the workers' performance. It is said that one of the potential harming factors at the workplace that could worsen the physiological strain and lowers one's human body function is heat. Longer period of exposure to heat can cause an effect to the human body physiologically like heat syncope, muscular cramps, and also heat stroke. This will naturally lower the worker's concentration and productivity and thus decrease the work efficiency. The negative effect of harmful exposure to the heat, such as heat stress, is common and natural in numerous industrial and commercial occupational settings. The involvement of operation of the worker with high surrounding environmental heat requires more physical activities or even wearing impermeable protective clothing have a high potential for incurring heat stress among exposed workers. Besides lowering performance and productivity, heat stress also increase the rate of incident and even threatening the worker's survival. This is due to heat stress that causes the escalating of thermoregulatory, cardiovascular and strains on the human body that could lead to emotional stress, which may cause the workers to become distracted and diverted from tasks and even ignore the safety procedures while performing their jobs. Wearing a personal cooling vest can reduce the heat stress for people in various industries where they are exposed to long periods of heat, as heat stress can cause thermal discomfort. Thermal discomfort can impact morale and work performance, and also can cause fatigue and lower productivity. By keeping them comfortable using personal cooling vests, people are able to function and perform much better, adding to productivity, and apart from that, any heat related conditions can be avoided. That is all from me. Thank you for listening.